Alright, so good morning. We are working today on rational or fractional exponents. Pause this, do what you got to do, but take notes on this because this is what we're doing today, and I'm going to go into this in two parts. The first part's pretty simple, the next part gets a little more interesting. So first things first, if I got something like this, 4 to the power of 1/2, the numerator of all of these is always the power above the 4. So like we never write, we never put in here this, and this all makes sense in just a little bit, okay? We never put 4 to the power of 1 because we already know 4 to the power of 1 is just 4. So I'm never going to write that in there, but just know from the basics, this is where we're going with it, okay? So this is the power. The numerator is always the power above the number that's going to be inside the radical, all right? And the denominator tells you what the root is. Well, this is the second root, or as we're familiar with it, it's the square root, okay? So the 4 to the power of 1/2 is the same as square root of 4, which we know is 2. Just like 9 to the power of 1/2 is equal to the square root of 9, which is equal to 3. And 25 to the power of 1/2 is the same as square root of 25, which is 5. Now, what's going on, just so, because you're going to see this building complexity as we move through this concept today. You're going to see it again, just to go for more examples. 8 to the power of 1/3 means, well, this is 8 to the power of 1, and this is under the third root. And the third root of 8 is 2. Okay? 27 to the power of 1/3 is the same thing as the third root of 27, which is equal to 3. And on the same token, 64 to the power of 1/3 is the same thing as third root of 64, which is 4. Okay? I'm going to pause this, be back with a couple more examples in just a second. You'll see how the power will always change a little bit as we move forward. So here we go. All right, sorry about that. Here we go. So here's some more examples. Again, now I got some stuff where the numerator is no longer 1. Basic examples of where the numerator is bigger than 1. So this is exactly how you write it out. Remember, this is the power above the 2. This is going to be under the square root. So this is going to be the square root of 2 to the power of 3, which is equal to the square root of 2 to the power of 3 is 8. All right, and now this is where reducing radicals comes in handy, because in this case we've got to reduce this correctly. I know that embedded inside the 8 is a 4 and a 2, so the final answer for this is going to be exactly 2 radical 2. Now this is an extreme example. I just put it up there, but I doubt you'll see one like this in today's work because a lot of it will simplify out to just equal whole numbers. But again, combining all the skills we've learned in the past, do not forget that you always got to do this. But this is in practice how you would do this. Remember, power above the 2. This is the root. Now let's do this one, okay? So now again, another one. So now this is going to be the square root, because that denominator, 16 to the power of 3, and that's equal to the square root of 4,096, which works out pretty nice because that equals exactly 64. This is how the majority of your stuff should look today, okay? So that's 2 examples right there, but now I got some more. Going further, I got this one right here, and I know that 6 to the power of 3 is equal to, well, first of all, let's just write this out. We know this is square root, 6 to the power of 3, which is equal to the square root of 216, and embedded inside of 216 is a 64, and, a 36. And a 6, so this is going to equal 6 radical 6. And now this one, square root of 5 to the power of 3, which is equal to square root of 125. And inside of 125 is a 25 and a 5. So your answer for this one is going to be 5 radical 5. Okay? I'll do a couple more examples and then we'll get going. All right. For the last of my examples for today, just some basic arithmetic with fractional exponents and stuff we learned yesterday, now combining the rules, all right? So feel free to pause this and write everything down as needed. First things first, when I got the same base but different exponents, I'm allowed to keep my base the same, and I add the exponents, and I know when I'm adding fractions, I only add the numerator. So 9 to the power of 3/2 times 9 to the power of 1/2 is the same as 9 to the power of 4/2, which we know this simplifies to 9 to the power of 1/2, which we know based on what I just showed you, 9 to the power of 1/2 is the same as the square root of 9, which equals 3. Okay? Now on this one, when I have the same exponents but different bases, I'm allowed to multiply the bases but keep the exponent the same. And I know that 27 to the power of 1/3 is the same thing as third root of 27, which is equal to 3. Now over here, now I got a power to a power. And I know by rule, I always multiply the exponents, okay? So that being said, I only multiply the 3 times the 4, which is the same as 3 to the power of, sorry for my messy handwriting, 3 to the power of 12/3, which reduces to 3 to the power of 4, which is equal to 81, okay? Because I got rid of the denominator there, so that was nice. So that means there's no root on this one. Now down here, just like we did learn yesterday, whenever I divide expressions with the same base, different exponents, all I do is subtract the numerator from the denominator. So when I do that, I'm doing 9 to the power of 3/2 minus 9 to the power of 1/2, which is equal to 9 to the power of 2/2, which reduces to power of 1. Equals that right there. We're going to see examples like this today, but now hopefully you got some good insight, and I will see you guys in class.